I'm talking, I'm getting the table or database information, or whenever I'm doing min, max, and const. And when I'm executing a query first time, it is going to make use of a result cache it is going to get the data from the storage layer. From the next time, it is going to get the data from the result cache. Now, the third one, let us discuss about the warehouse cache. For that, what I'm going to do is I'm going to create a database uh, called a performance test. In that, I'm going to create a table called transactions. It's the same thing what you have done previously. Mm, it will load transactions. Let me log into my AWS as well. Let me log into my AWS. Let me share my screen. Going to my S3. Let me upload the files. I have a transactions file. If I open the file, I have transaction date, customer ID, transaction ID, and amount. Because I know the file, I'm creating a table with it. So I'm create table transactions, transaction date, transaction ID, customer ID, and amount. Great. Now I'm going to create a stage called a performance stage, and the URI I'm going to specify. Because I have only one file I removed, I can directly pass on. Let me list the stage. There is one transactions one CSV file. What I'm going to do, if I copy, I'm going to copy this file into my table. So copy into the transactions table, whatever I created here. And from where I copied it from the, I have already put the file, or I have staged the file into performance stage. So let me copy into the table from the stage. And if you see the pipe, the delimiters are pipe. So I'm passing on file format with the delimiter pipe, skipping that. Now if you see, we have 100 records. What I'm going to do to have a good analysis on this performance tuning, I'm going to make this 100 records into 100 million records. Before making 100 records into 100 million records, let me do few statistics. There are 4 columns. Let me find the distinct values on all the 4 columns. What are the 4 columns I have? Transaction date, transaction ID, customer ID. Let me see if any of these are unique. Select distinct transaction date from transaction. Out of 100 records, 93 are distinct. Let me do it on transaction ID. That is, this is a unique column. Transaction ID is, out of 100 records, there are 100 distinct values. That is, this is a unique column. Let me see the transactions customer ID. It is also 100. That means this customer ID is also unique. One thing we can think of is each customer is having one transaction ID in the current scenario. On some customers have done the transaction on a similar dates. Of course, amount can be same or amount can be distinct. But what is important is we just took what are the distinct values, transaction ID, customer ID are the unique values. What I'm going to do from the transactions table, I'm going to create a bigger table with the same definition. I'm just calling it as a transaction sludge. Same columns, transaction date, transaction ID, customer ID, and amount. And I'm going to insert the data into this transaction sludge from the transactions table where we have the 100 records. From the transactions table where we have the 100 records, let me insert into a transaction sludge by doing a cross check. If you see, from transactions, cross join transactions, cross join transactions, and cross join transactions. 4 times I'm joining. And what I'm going to do, for every transaction ID, I'm going to add a random number until the range of 2000. If 2000 is coming completed, again it adds some random numbers. And transaction ID, I'm going to add a random number again. So that this transaction ID is made unique. Whereas your customer ID, I'm repeating in the join. Team, you're able to hear me?
Yes, Satish.
So customer ID, I'm going to reuse. Similarly, the amount. A dot customer ID and A dot amount. But randomly, I'm generating a number per transaction. And for the transaction date, I'm adding a random number until the range of 2000. Let us see how this query is working. We know that query ID will be generated for both running queries and processed queries. You can see this query is running. Still, I can go to the query ID and see how my query ID is performed. Go to the profile. See the down. It says it is scanning, then a Cartesian join is happening. Then on the Cartesian table scan, again a Cartesian join, again a table scan, a Cartesian join. And it is inserting into the table. Right now, the status is running. Let us wait for, now it has finished. You can see how many number of there are 100 million rows. There are 100 million rows. Now if you see, there are 100 records in my table. There are 100 records in my table. When I did a Cartesian product join, 100 became 10k. See how the query profile shows how your query is performing. These 10k records again joined with 100 and you have 1000k records. These 1000k records again joined with 100 records, Cartesian product join. That is, each record joins with 1000k records. Like that, we have 100 million records. And that has inserted into the table. Now we have 100 million records. We just generated using a join, cross join. Out of from 100, I have generated 100 million records. What I'm going to do, let me again take the distinct values from this. We have taken for transaction ID, transaction date, transaction ID as well. Out of 100 million records, 4718 are distinct dates. Why 4718? We have given a range of 2000. When I'm doing randomly until 2000, you add. Once the cycle is done, again you start with 0. Random, my transaction ID, I want it to be unique. Let me see if they are unique or not. See, 100 million. These 100 million are my unique transaction IDs. Customer ID, what I have done, I have reused my customer ID, and the customer ID has 100 distinct values. So even now when I see, there should be 100 distinct values. Is if I can correlate something, these 100 customer IDs have unique transaction IDs. Probably the transaction is done multiple times within the same day. Same 100 customers, what we have, they have generated a new transaction IDs. Probably on a same day, the transactions would have been repeated. Now, what I am going to do, I'm going to create I'm not going to create, I'm going to first alter the session, use result cache is equal to false. Because now I wanted to take the statistics. And I am suspending the errors. I will do first errors. Okay, it is suspended. Now, let us first query what is there in the transactions table. When you did it for the transaction table, let us see. Select star from transactions. Go to the query ID. All these 100 records are there in one micro partition. I will do it on transactions launch. Just wanted to see how many micro partitions. Hundred million records are present in 63 micro partitions. Let me copy this query execution time. I'm copying the query execution time. I wanted to take the statistics. It took 29 seconds. Okay. Scan. Now let me suspend the warehouse. Again, let me run. It will take almost similar 29 seconds. Let us validate. It took around 26 seconds. Let me go and check the query. Copy paste. See, it has scanned 1002.15 bytes from the 63 micro partition. There is a lesser time, probably, maybe because it did not have any time synchronizing. And it spent lesser time on remote disk. Remote disk is like going and fetching the data from your storage layer. And it was initialized faster. There is a minute difference in respect to time, 29 and 26 seconds. Without suspending a warehouse, my warehouse is still active. No, it got suspended. Why is it? Let me change the warehouse suspend time to more. I go to my first warehouse. Let me configure it to 5 minutes. Now let me rerun from the transactions launch. It took around 27.96 seconds. Go to the query ID. Let me have this as a standard. I'm deleting. Almost similar runtimes. Copying the query execution. What I'm going to do, again I'm going to rerun when the warehouse is active itself. the same query. It will not run from the result cache because I have disabled the result cache. Usually, when I run the same query, it should have come from the result cache. It also took a similar runtime, but there will be one difference. There is a processing time, synchronization time, and initialization time. Let me but if you see, there is no remote disk IO or local disk IO in my secondary. And if you see, the scanned process is 100%, similar amount of bytes is scanned, but look at the difference. Percentage scanned from cache in the second run is 100%. Whereas in the first run, it is 0.00%. It will be more evident if I suspend the warehouse. Let me suspend the warehouse. Let me run for one particular transaction rate or one customer ID. I'm just running for one customer ID. Let us see how one customer ID is going to take time. If we see, let me make a note of this. This is for one customer ID around 3 seconds. Exactly if you have to specify 3.11 seconds. This is, I ran this when the warehouse is suspended. Now the warehouse is active. Let me rerun this. See, it took 1.79 seconds. We compare it side by side, 1.79 seconds. Here the difference is very much evident. Let me see what is the difference. See, the difference is the percentage scanned from the cache. When the warehouse is suspended and when I ran, it is 0%. But before I ran the query, I did not suspend the warehouse. I ran, it took 100% from the cache. And if you go up and see, it took 19% of the time in getting the data from local disk. It did not go and fetch the data from the remote disk at all. If your warehouse or if your query is going and getting the fetching the data from the storage layer, that is called a remote disk. Now every virtual warehouse has its own certain amount of called a local SSD, local storage. When the Snowflake is fetching the data from local SSD, it is called a local disk IO. Now, for the second query, whole of the data is fetched from the local disk IO, nothing from the remote disk IO. That means the second query did not even go into the storage layer. It fetched everything from this local disk IO and this cache. It's called a virtual warehouse cache. Let me halt this presentation for a bit. Any questions? First thing, anyone? What I have done, if I have to summarize, just a second. not able to open the PPT.
So one question.
Yeah.
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 So suppose if we run the query, right? Let's say select star from the table, right? So the entire results will be stored in the cache, right?
Yes.
After that, if I run that query for a specific customer ID, right? In this case, so it will again connect my Snowflake database, or it will get the result from that the whole results of from the cache,
They'll get it from the result cache.
result cache. Okay.
No, not the result cache. Here, in
Ah,
provided we turned off the result cache, it gets the data from the virtual warehouse cache.
okay.
This cache percentage is nothing but a virtual
Mm.
warehouse cache. Whatever is the cache percentage I have noted down, right?
Mm-hmm.
This is whenever you have this percentage scan from cache is 100% and there is nothing
Mm.
from cache, getting it from remote disk I/O. It's like whole of the data is got it from the virtual warehouse cache. Okay.
So then, so in this
So
case, Snowflake will not look for any specific conditions, and it looks for if the results, the data will be stored for the specific table. If any query fired on top of the table, it will use that particular virtual warehouse cache, right?
correct. So first time what happened when I ran a query, your query went into the storage layer,
Mm.
fetched the data, and it gave you the result. Now this storage access is called the remote disk I/O.
Mm-hmm.
And when it is going through the virtual warehouse, that data is reposited in the local SSD storage of virtual warehouse. Now next time when you say where customer ID equal to this, where transaction ID equal to
Mm.
this, now because it's already present in the local SSD, it will not go into the database storage layer. When this result cache will be invalidated, if when your virtual warehouse gets suspended, obviously the data is burst, this cache is burst. Or when the underlying data changes, when the storage layer data changes, this cache will become invalidated.
Okay. But generally, we will suspend the warehouse for a specific within a specific time, right? If you are not using for 10 minutes or 15 minutes, right? So in this case, all my cache will become invalid
Correct.
after the 10 minutes, right?
Correct. So that is where the use
Mm.
cases comes into the picture. Now, let's say your COE is going for an important meeting with some client.
Mm.
They are going to obviously COE is going to walk through the presentations, the decks or the
Mm.
reports. Now, before the meeting, the best practice is whoever is assisting the COE, they will just execute the dashboard once. Two reasons. One, the result cache is formed. Two, your virtual warehouse cache is there. And we see to that whatever is the warehouse we assign to the COE,
Mm.
it is never auto suspending
Okay.
because we
Mm.
will have it as an X small and it will never auto suspend because for COE,
Mm.
the runtime
Mm.
is more important than the cost of saving the cost.
Mm.
If that warehouse, if X small warehouse is active for 1 hour, at max it's going to cost him only $3, $3.5 or $4 for 1 hour. But the performance of your report, when in a very critical meeting, there is no lag in fetching the data from the report because your result cache is active because you already dry run the dashboard previously. Everything there is a result cache. In case if the COE is going to select different options, for that also we are prepared. How? Because we are not suspending the virtual warehouse. Your virtual warehouse is up. That means your virtual warehouse cache is active. the result cache will be much faster than the virtual warehouse cache. Let me turn on this result cache. Same query if I run. It took 3 seconds. Now basically it went and fetched the data from the storage layer. Let me rerun this query again. Result cache took 38 milliseconds. See, 3.11 seconds. Virtual warehouse cache is 1.79 seconds, and result cache is 38 milliseconds. You can see fetching the data from result cache is faster. Next, fetching the data from the virtual warehouse cache is faster. And the least is getting the data from the remote disk IO or the storage layer. Any questions? The main important thing, if you are at a higher level, you get whether you have to see what are the benefits of not suspending the warehouse, or giving it more time for an auto suspend. You can give 1 hour as well. So evaluate based on the needs. What is the need? You want to save the cost, or you wanted to have absolutely critical faster performance. If it is a developer, right, it's not necessary, because developer keeps changing the queries and all. It's not necessary for whatever is the warehouse you are assigning to a developer and QA. You should for sure auto suspect. Okay. Any questions? Is everyone clear on the virtual warehouse? Any questions? Let me know. This is a result cache. This is a virtual warehouse cache, and this is getting the data. How we will know that you got the data from virtual warehouse cache? For virtual warehouse cache, all the data is processed from the local disk. There is nothing that is processed from remote disk. This is the percentage of the time. In 1.79 seconds, 19% of the time it's spent on local disk. And the main important thing is bytes percentage scanned from cache. This is 100%. Whereas the initial run is with 0%. So whenever you know that there is something of percentage scanned from cache, understand it's from a virtual warehouse cache. If it is from a result cache or metadata cache, it would be mentioned in the, if I go to the query ID, it says it would be mentioned here, query result reuse or metadata reuse. Any questions? Sometimes what will happen? I'm just opening one document. Sometimes you get a data like this. Let me sharing my screen. You get the data. If you look at the statistics, okay, there's some time in 2% it has spent in local disk I/O. Percentage scan from the cache is 100. Good. But you see an additional column called as spilling. Bytes spill to the local storage. Right? Oh, sorry, Dick. I think I need to restart my system again. But I'll complete this topic when we can you see my screen?
Yes, Sadish.
Okay. Better we go for a break. I need to restart my system, then I'll continue my talk. Okay. Go for a break and we'll be back. Yeah. Any questions until now? Sharing my screen. If you go to the history, if you go to the profile, let us see where the caches are more. Result cache. Refresh. Assuming that this is from the cache. Yeah, 1.8 seconds. Here it took from the virtual warehouse cache. And after that, pruning, and there is nothing after that. Sometimes you get a profile like this, query profile. Percentage scanned from the cache is 100%. But you see bytes spilled for the local storage. What is this byte spilled to the local storage? Previously, I was mentioning you. Virtual warehouse will have a local SSD. Whatever is the data that is being present in the local SSD, that is stored as a cache, virtual warehouse cache. The storage will remain the same. Now, if something is not fitting into the virtual warehouse cache, into the cache of that local SSD, now that bytes will be spilled to the local SSD. So, bytes spilled to the local storage. That is called this spill. Now, whatever is there in the cache, virtual warehouse would be like Snowflake would be able to read the data faster. But whatever is spilled to the local storage, then it has to do more amount of processing to process the data of reading the data from local storage. Sometimes there can be more data. In that case, the data spilling will be to the remote storage as well. You will get the query profile like this. Bytes spill to the remote storage. Now, whenever you see this spilling, your queries will be running very, very slow. What can be the reason for the spilling? What you can do to avoid the spilling? Keep proper the where conditions. See to that your queries are not, Cartesian product join. See whether you have running your queries on an appropriate warehouse sizes. You are running a complex query and using an X small warehouse, the spilling might be possible. So increase the size of the warehouse accordingly. Okay, spilling is nothing but when your cache is not able to hold huge amount of data, it's spilled to the local storage or it's spilled to the storage layer. Any questions in the caching? We'll go to clustering. Same queries we'll make use of it. What we'll try to understand what is a clustering. If you see, we have done, whenever you are running a subset of the query, it is taken from the cache. What I'm going to do, I'm going to create one more table called a clustering table. Let me get the data. I'm going to create a table called clustering. Transactions cluster table. Same amount of columns: transaction date, transaction ID, customer ID, and amount. The only thing what I'm doing is, when creating a table, I'm adding clustering by transaction date. Added clustering better. What I'm going to do, whatever I have the data in the 100 million records in the transactions large table, I'm going to insert into this transactions cluster table. Insert into transaction cluster table. Select start from the transactions. Understand where I'm inserting, insert into, and understand where I'm using a copy into. Copy into is when you are trying to load the data from files. Insert into when I am loading the data from one database or one table to another table. So 100 million records, I'm inserting into a transaction cluster data, and I'm using, it takes some time, 100 million records. Meanwhile, let me go to the documentation. My 100 million records are inserted. What I'm going to do, before we go, let us try to understand the micro partitions in a better. Let us understand the micro partitions in a better. Let us take this example. It has a table, one type, name, country, date. What we have seen, as you insert the data, micro partitions would be created. If we see, first 6 records went into micro partition 1, 243232, 243232, and the data in the micro partition is stored in a columnar storage, like how we have seen in the previous class. If you see, we talked about micro partitions and how the data is stored. As you insert the data gets into the micro partition. Similar example I'm taking from the documentation. Now there are 24 records. 1 to 6 records are there in the first micro partition, 7 to 12 in the second micro partition, 13 to 18, and 19 to 24. There is no indexing, nothing. Just that the data is stored in a columnar storage. This is the data. Let's assume that you ran some query. Let's assume you ran this query. Select name comma country from T1 where type is equal to 2 and date is equal to 11. What will happen if it has to fetch the data from here? This is the same thing what was here. What we will discuss. 243232. 243232. And 11 twos. All the dates are here. It's the same thing. Now with respect to this query, select name comma country from table 1 where type is equal to 2. Now check where type is equal to 2. It is there in all the micro partitions. And where date is equal to 11.2. 11.2 is present in only 3 micro partitions. Now it is going to eliminate this micro partition 4. It is not even going to scan this micro partition. Same thing. I said how the data will be queried based on the ranges and all. We have seen this. Now, because 11.2 is not present in the micro partition 4 itself, min and max when it says calculates, it calculates 11.3 and 11.5. There is no 11.2. So it will not even go and read the micro partition. So when you take a profile like this for a query, you will have partitions total are 4, partitions scanned are 3 for this query. It scans only micro partition 2 and 3 to fetch name and country. Now if I do a cluster by, one way is I'm altering the table and I'm clustering by date and time. Now what happens? This data, whatever is there in the micro partitions, it will be redistributed. It will not sort the data within the micro partition. Why? Because once the micro partition is created, it is immutable. That is, no data can be altered within the micro partition. So it creates a new micro partition 5, 6, 7, and 8. And what it does? It does first on the date. It orders the data by date and then time. So when it orders the data on date, all the 11 twos will come together. Then 11.3, 11.4, and 11.5. It's like it groups the data based on the date. And within the date, it groups based on the time. All the twos are together, threes and fours. Here, 5, 1, 1. Here, 11, within 11.4, it has 3, 4, 5. Within 11.5, it has 5, 3, 2. So it groups the data based on the cluster by what you have given. First, your first preference is given to the first column you specified. So 11.2, 11.3, 11.4, and 11.5. Within this 11.2, the types are grouped. Now, same query. Select name comma country where type is equal to 2 and date is equal to 11. See the number of micro partitions it scans here. 11.2 is there in the 2 micro partitions and type 2 is there in the 1 micro partition. So out of the 4 micro partitions, it scans only 1 micro partition. Any questions, team? Please let me know if someone is not able to understand. So your statistics for this kind of query will be total partitions are 4, partitions scanned will be 1. In this case, that time your query is running will be much lesser. Your total execution time will be much lesser because the percentage or the micro partition scanned is less. Anyone did not understand or anyone has any doubts what this clustering is doing? Clustering is rewriting the data into a new micro partitions. And this time when it is rewriting the data into a new micro partition, it is going to group by the similar data. Whatever is given in the cluster by column. Whatever the columns are given in the cluster by statement. In my example, what I have done, I did a cluster by on transaction date. That means all the transaction date should be together. And it takes some time for Snowflake to rewrite the data into a new micro partitions. That is the reason if I do select star from a transaction launch, or I'm randomly doing something on a transaction date. It still shows, sorry, I need to do it on the transaction cluster. Before that, just observe this. Transactions large data is present in 63 micropartitions, and transactions clustered data is present in 78 micropartitions. It's the same data because I inserted the data from transactions large to transactions clustered. Why is that there is an increase in micropartitions? Because it's up to the micropartition how it wants to store the data. Let's say we have a table. I'm giving something randomly like this. Let's assume this is my table. And this data has to be distributed in previously 2 micropartition. Let's assume 2 name 1 name 1 ID. Then link or name 2 name 2. Same data could have been redistributed in like this as well. Now that redistribution is in 3 micropartition. Sometimes it's up to the discretion of Snowflake how it wants to maintain. Here it is in 2 micropartitions. Here it is in 3. Because this micropartition size can be still 50 to 500 MB. Now, even when you are inserting the data into a different tables, don't get worried that the number of micropartitions is changing, because somehow for you it may store in 10 micropartitions. If I'm loading the data, it may store in 12 micropartitions. It's up to Snowflake. And I just inserted the data from transactions to the transaction cluster table. I already clustered. Still, the clustered would not have been affected. How I'm saying it, the clustering is not affected. If I go to the query ID and see, still the number of micropartitions scanned are 78. And I'm querying it on transaction date. And I clustered on the transaction date. So I'm saying the clustering hasn't affected. That is, the reorganization of the data has still not taken place. Is there any other way you can say without query? Yes. That is called a clustering depth. What is a clustering depth? Let us understand. Let's say you have, consider a table consists of 5 micropartitions. Consists of a table consisting of 5 micropartitions with values ranging from A to Z. Now, if A to D are in one micropartition, E to J are in one micropartition, K to N are in one micropartition, O to S are in one micropartition, and T to Z are in another micropartition. Here, anytime you query, or no, there is no overlap first. There is no overlapping of data between the micropartitions. And anytime you query, it has to fetch the data from either one micropartition, where ID equal to 2. Sorry, where alphabet is equal to B. It goes and gets the data from first micropartition. Where alphabet is equal to E. It goes and gets the data from second micropartition. So the clustering depth is 1 because it has to go and get the data from one micropartition for sure. But there are no overlapping micropartitions. Let's say if K to N are in third micropartition, L, M, N are repeating in the fourth micropartition, and QRS is repeating in the fifth micropartition that is present in the fourth micropartition. Let's see if the data is distributed into the 5 micropartitions like this. Now query anything. What is the average depth? You query A where alphabet is equal to B. It is going to fetch from one micropartition. But if you are going to say where alphabet is equal to R, it can fetch from it is going to fetch from fourth micropartition and fifth micropartition. Here the depth is 2 and overlapping micropartitions are 3 because third, fourth, fifth micropartitions are overlapping. Similarly, if my K to Z are in the same micropartitions, there are alphabets K to Z in third, fourth, and fifth. Now, still my overlapping micropartitions are 3 like before. But the depth, average depth is 3. Here it is 2, here it is 3. Anything you choose where alphabet is equal to Y, it can be present in the 3 micropartitions. Anyone who did not understand this illustration, what is this depth called? Here if you see, what is the depth on name? Here name 1 is present in 2 micropartitions. So overlapping micropartitions are 2, there are only 2 micropartitions and the depth is also. Let us see here. If we see on the name, there are overlapping micropartitions are 2 and depth is also 2. Because if it has to fetch the name, for sure it has to fetch the data from one micropartition. In this case, the depth becomes 1. There are no overlapping micropartitions. Here for all the records, the depth becomes 1. Similarly, if I have to see the depth for my tables, go down and see what is a clustering depth on a transaction cluster date on a transaction ID. What is that? 1 second. So clustering depth is 78. I'm doing this on a table that I clustered. The total number of micropartition itself, it says 78, and it is showing the clustering depth as 78, which it means that the clustering has still not taken into effect. Any questions? You do on the transaction date, everything will be in 78. Customer ID 78. Not only on the cluster date, you can do it on the transactions large also. Here, the number of micropartitions are 63. So the clustering depth is going to be around 63. Any questions, anyone? Let us give few minutes for the clustering to be effective. Meanwhile, someone has any questions, let me know. It will take some time. So let us proceed with the other topics and come back. Anyone who did not understand cluster why do we do clustering? Clustering will redistribute the data into micropartition so that the number of micropartitions you are scanning are less. That makes the process faster. Any questions? Okay. Meanwhile, let us do one assignment. Let me see if I have any assignment for you. No, there is no. What we will do is you to create the same table, whatever I created, but don't create a new table, but alter the table to 1 second. Let me ping you the data what I have done. I'm pinging you in the chat. Insert the data into a transaction log. Note down the statistics of any two transaction IDs. Anything like where transaction date is like this, or any other date. Pick any date and execute these commands. Note down the performance of both the transaction dates, like how I copied into my Excel. Everyone do this. So execute the SQL commands, whatever I have given, and note down the performance of any two transaction date. I want everyone to pick different transaction dates, not the transaction date I have given. Pick any two transaction dates and note down the statistics. Whoever has captured that statistics, raise your hand, please. Anyone who has taken the statistics, please raise your hand. Anyone facing any challenges? Why it is taking so much of time? I have given you all the queries, right? Okay, take 10 minutes break and we'll be back, Tim. Team, any questions? Let me check if the clustering has become effective. Not yet. Okay. Let us continue with the other topic and we'll come back to the clustering because clustering still hasn't become effective yet. If I'm seeing even on the clustering date, transaction clustering date, if I'm checking the clustering depth, still it is 70. So it takes a while for the reclustering to be effective. Okay. Now, meanwhile, let us talk about another way of fine tuning. Until now, if you see related to the performance, we could have seen materialized views. Now we talked about the clustering, which we haven't seen still the impact of it because clustering is still being effective. Then the third one is there, search optimization. What is search optimization? We are not going to do anything practical here, but we have to understand what is search optimization. If I go, when were we doing the materialized view? When we are running a complex queries, aggregational queries, complex, and it is taking usually a long time, and that query is being frequently used, and the base table data is not being changed. That is when we go for materialized view. When do we go for clustering? Clustering, at max there will be 3 columns you can go. On what? If you are using the in the where conditions, you are using a particular query repeatedly, and that query performance has degraded over a period of time. That is the kind of a query what I am running, where I'm running a query similar to where transaction date equal to this. This is the kind of queries I'm running on transaction date. With the time, if you have seen the degrade in performance and the table size has exceeded over 1 TB of data, and with the time if you see the degradation in performance, that is when we go with the search optimization. Sorry, that is when we go with the clustering. Whatever we have seen is not at all a use case because we have 100 million records, but that 100 million records are present in just 1 GB of data, not even 1 TB of data. First criteria is your size should be over 1 TB of data, and with the time, like over period of 1 month, as you are increasing the data into the table, you see the similar queries what you are running before are taking a longer time. That is when we'll go on the clustering key. And clustering key we do on where on the columns on which you are doing filtering using a where clause, or you are using these columns in the join conditions. That is the use case for clustering key. Then there is another thing called is search optimization. First, what is search optimization? Let's say you are running the similar query, you are having the same thing. Because you know on what you are using a where clause, it is fine. But you are not aware which column you will have a where clause. It can be the customer ID, It can be the transaction ID. It can be on the amount and all. When you don't know on which your where clause is going to be, the where clause can be on any column on the table. If you have 100 columns, you can randomly query any column. So for the point lookup queries, when you are not aware what kind of a where clause would be coming in, that is when we go for the search optimization. How search optimization works? Improve the performance of a selective point lookup queries on the tables. A point lookup query runs only one or a small number of distinct rows. What are point lookup queries? Example, if I have to show what are the point lookup queries. These are the point lookup queries. Where ID equal to 2, where column 2 equal to 1, where column 3 equal to 3. These are all the point lookup queries. If you see where column is equal to this, where column equal to this. These are called the point lookup queries. Now, what is this search optimization? Search optimization is nothing but you enable a table for search optimization. How do we enable? Just say grant add search optimization on the schema. No, that is alter table, add search optimization. So your search optimization is on the table. You don't specify what column and all. On whole of the table, you add the search optimization. Then when you add a search optimization, what happens? In the backend, a Snowflake service will run. A maintenance service. It creates an access path with the data that is present in the table. Let us take an example and let us see the search optimization and compare. Just we should be very aware like which kind of an performance tuning we will be doing in which scenarios. We'll just randomly, I'll just give using a small data. Let's say we create a table, test table with ID. Let me switch the role to account admin. Account admin. First warehouse. Performance test is the database. I'm creating a table, inserting certain values. I inserted certain values 1, 3, 4, and dates. Select ID, column 1, column 2, and column. Now, let me insert certain values. Let me run few queries. Even before running the few queries, if you see the show tables, name of the table, test table. It has 5 rows. And you can see something like a search optimization, it is off for all the tables. And if we remember, we created one cluster on transactions clustered date. On what it is created? It is created on a transaction date. And for that, automatic clustering is on. There is an option for search optimization. It is turned off. What I'm going to do, I'm going to alter and I'm going to add a search optimization on the test table. Not going to do anything. See the table now. It says your search optimization is turned on. And you can see there are two more columns related to search optimization. Search optimization bytes is 0 and search optimization progress is 0. Let us give 2 minutes. See now, search optimization progress is 100% and search optimization bytes is 1, 2, 3. 1, 2, 2, 3, 6. Previously, you have seen 0 and 0. Now, whenever this search optimization progress is 100%, that means that Snowflake search optimization process has got the access path for all the column data. It creates an alternative access path. Now, whenever your queries are running, like this point lookup queries, they tend to be faster on a search optimization than what when your table doesn't have a search optimization. Because this path is already stored. If we go, we may not be able to understand with the smaller query. If you see, partition scanned and all is 1 and cache it's 100%. But nowhere we talk about search optimization because Snowflake automatically determines it. The only thing what we know is when there are multiple columns, you don't know what kind of a column you are going to trigger, then you have a search optimization enabled. That would improve the performance. And look at the way search optimization is one of the several ways to optimize. I have already said we can either cluster a table or we can have a materialized clustering on what you can do on the range searches, on the equity searches, where date is equal to, where transaction ID between this and this, the range searches. Search optimizations per service only speeds only equity searches, where ID equal to this, where name equal to this. For that kind of equity searches, search optimization will be helpful. And materialized view, you know when it will be helpful. Materialized view when you are doing a complex aggregation functions which you will be reusing repeatedly. Now, does search optimization take space? Yes, because when it is storing the access path for each and every column, it takes a storage cost. And in order to create the access paths, it takes a compute cost. Materialized view, does it take storage cost? Yes. It is going to pre-store, it is going to store the pre-computed data. And is it going to take compute cost? Yes. To get the pre-computed data, it needs compute resources. Clustering of a table. Does it take storage cost? No. It clustering table just what it does. If there are data in 4 micropartitions, it takes the data from 4 micropartitions and reclusters. So if there is 1 TB of data here, the 1 TB of data will be redistributed. And these micropartitions will be disabled. So Basically, you are holding only one data. Just that when you define a clustering key, it is distributed. So it doesn't, clustering of a table does not take a storage cost, but it takes a compute cost. For redistribution of a data, it needs some compute resources. Now, how such optimization will vary? Why it needs a compute services? If you go to my account section, you will have something entry for search optimization service. Similar to this for Snowpipe and materialized view maintenance, how we'll get something for search optimization. Let me add a new record to the base table. Before adding, if you just see the show tables, this is how the data was. Search optimization, let me expand it and take it. Search optimization byte. And this is how the data was. Search optimization progress is 100%. That is, all your access paths are stored. Now let me change the base data. Let me insert a new record to the base data. One record in. Now go and see the show tables. Now the rows are 6. Search optimization has become 0. And it will become 100% when for the change in data also it has captured the access paths. Any questions, anyone? No, after a while, this search optimization progress also will become 100%. Any questions? Okay. Meanwhile, let me go and see if the clustering, whatever I have been doing, is it effective or not. See now, previously it was 70. What was the number of micro partitions? It was showing 78. Now it is 6. Let me see the data now. That means my clustering has been taken place, the clustering key. Now let me run same data from both the transactions. Or let me change. How long each of these queries will take. My transaction is large. Before that, let me keep suspending that. I'm going to suspend the warehouse, first warehouse. Let me suspend. Let me also again reconfirm that the cache result is false. Now 1225 I'm going to run on both transaction large and transaction clustered. And let me capture the statistics. It took 1.18 seconds. Go. And capture that 1.16. It took this much amount of time. Now let me again suspend the warehouse. This time I'll get the data from the transaction cluster data. Same, it took 2.2501 records. Look at the time it took. 853 milliseconds. Go to the query area and check. Out of 64 micropartitions, it scanned only 5. That is why your total execution times come down. Oh, let me put it for comparison. There is no percentage scanned from cache. Why? Because both the times I suspended my warehouse central. Why it took 1.16 seconds and why it took 794 milliseconds? If you go and see the query profile, this is where it is taking. The pruning is coming into effect. Here, partition scanned is 63. Whereas here, the partition scanned is only 5. And observe one more thing. Here, the byte scanned is 163.92 MB. Whereas in the clustered, because the similar data is grouped together, the partition scanned is lesser than that. Any questions? We see the clustering has improved the performance, though it is negligible here in terms of it is in just milliseconds. And how I am saying that the clustering is effective? First, I saw the clustering done, it reduced. And then when I run the queries, you can see out of 64, only 5 micropartitions are being scanned. Any questions, anyone? Is anyone having a doubt which performance or approach you should take and in what scenarios? Team, speak up something. No, Arun, is it clear for you, Arun?
Yes, that is, but again, I felt, I need some more time to review whatever, if you had right, so I have to see this recording.
Okay.
And so overall, yeah, it's clear. I think it is similar, right? Like in other database, it's doing it. The only thing is how Snowflake in terms of this percentage wise it is doing, right? Okay, that we need some more time to understand more.
Yeah, but you should be able to see what is happening in the query profile.
Correct.
Because here you can see that why all the micro partitions has to be scanned if you are only querying for single date. That is when we saw the clustering depth and we defined the clustering on the transaction date. If your, let's say your reports are running daily using a day-wise filter, cluster it on day-wise, or your reports are running on a month-wise, then clustering it on a month. Moreover, in most of the cases, we don't even need to think about clustering because Snowflake naturally clusters. What does that Snowflake naturally cluster means? We have a table, we have ID, and date of joining. In the system, how the data will come? One, if today is June 6th, all the dates related to June 6th will come into the system. So this June 6th data will go into the micro partition first. So let's say we are going into micro partition 1, micro partition 2. So ID, I'm just taking name. So 1, 2, it is data joining. June 6th will go. Of course, date of joining, again tomorrow, few people will join. June 7th, June 7th, and 6th. You see here, this naturally your Snowflake is clustered because you are going to query this table on the date of joining, and the data is already distributed properly because we are getting a data regularly, and regularly as you insert the data, new micro partitions are created. Here you need not do anything because it is naturally clustered because your micro partitions are created as we inserted the data. The only problem comes is, let's say, initial load you are doing, some data load you are doing. If you are going to have the similar data loaded like this, one is joining on June 1st. Then you insert the data related to this. Then again you insert this data. Then you insert this data because micro partitions are created as you insert the data.
Right.
Then you insert something like June 8th, then 3. Now here the data distribution will be wrong, or it will not be as intended. It's not clustered properly. Now you will have something like this: June 6th here and June 7th. Then June 6th and June 7th. Then June 8th and June 6th. Someone is querying on June 6th in this scenario. When you look at the clustering depth, it is at 3 different micro partitions. Whereas here it is in 2 micro partitions. June 7th is present here in 2 micro partitions. Here it is at 1. I'm just taking a smaller set of data for explanation. Yeah. Here, when you look at the clustering depth, okay, if you find it's closer to total micro partitions, that is when we go for the clustering. Even here also, even if it is 2 micro partitions, the impact is not going to be much. You will sometimes both the runtimes can be same if you're querying this or querying this. You need not worry about the clustering. Because even if you do the clustering, there is no proper advantage you get because already the runtimes are faster. In this case, when your runtime is, if your table like this has crossed 1 TB of data, and the same query what you are running 2 months back is running very slow now, that is when you check the clustering depth and define the clustering keys. What will happen? Now all this data, once you define, they will be redistributed like this. Micro partition 5, 6, 7, and 8. And these are discarded. Now any queries you run, they will query on this micro partitions. So even whatever we just talked about the ways you can do the clustering, but naturally there is a natural cluster that happens as you insert the data. Most of the scenarios we need not even think about the clustering. As I said, only when the table size is growing and with the performance has decreased, then only think about the clustering. Others, any questions? If you go to the worksheet, I have done the clustering on the transaction date. You need not have this. If you see transaction date, I have seen the clustering depth as 6 or 7. 6. Transaction ID, go and check. Out of some 64, it is still 64. Clustering ID, customer ID, it is still 64. So your data is grouped together based on the transaction date, because that is the date that is on the column on which I am going to query most of my columns. Anyone has any questions? Okay. No, well, I will take a few more minutes to discuss on just a second. Information schema and account usage. And what is the difference between information schema and, yeah, someone is having something.
Yeah, Satish, I'm asking you can do the to check the clustering, right? You can do on columns. So can you do on stages also?
No.
Okay.
But you can do it on external tables.
Sorry, I didn't get you.
You can do it on external tables. You remember we created an external table.
Yeah, correct.
You can do it on external tables.
So it is specific to only table level.
One second. Let me confirm if you can do clustering on it. You can do it on materialized view for sure, but let me see if you can do it on clustering where it is possible. I doubt if you can do it on external table, but on materialized view for sure you can do. Because clustering will be there when you have the data distribution in micro partitions that we have in materialized view, but not in external tables. That is why I got that. External tables, I'm not sure if you can do. Yeah, you cannot do on the external tables. You can do it on a materialized view.
Okay, thank you.
Let me show you that. I'm trying to get some document, not finding it. Clustering key, you can cluster materialized view as well as tables. Okay, but we will not be able to do a clustering on, because external tables does not store any data in micropartitions or even stages. They don't store the data in micropartition. The data is stored when you insert the data into a table. But materialized view, why is it happening? Because the data is physically stored in the micropartitions for materialized view. So you would be able to do the cluster because the data redistribution will happen.
Okay, thank you, Satish.
Now, we have seen that there are information schemas. What this information schema meant? We have already seen few of the things. Load history, copy history. When I talked about a snow pipe, you can go and see in the copy history. You will have a load history and you can see the data, whatever are the copy you are doing, how the files are being processed, you can see in the load history. If you wanted to see the copy history, then we do the functions, information schema functions. I think I told about this somewhere. I think during streams. If you are querying from information schema load history, this is at a database level, information schema and load history. If you are querying from this something like a table, information schema dot copy history. This is information schema table functions, and this is from the views. What is information schema? Whatever. By default, when you create a database, two schemas are created. So the Snowflake information schema consists of set of system-defined views and table functions. If you see here, this is from a view, and this is from a table function, because copy history you are calling from a table function that provide extensive metadata information about objects created in your account. So you can view this information schema as a data dictionary. And this information schema is based on the SQL 92 ANSI information schema. Now, what is the views content? Views contains the objects related to the database as well as for few views related to an account level. Table functions for historical and usage of data across your account. Now, information schema is read only. We know that because initial class itself is so, we cannot create any tables in the information schema. Queries in the information schema will not guarantee consistency with respect to the current data. So it will take some time for your data to reflect in the information schema. And when you are querying the information on the information schema, you will have access to the objects that for which your role has an access to. Let's say your information schema has information related to all the tables, 10 tables within your database. But as a user, you don't have access to 5 tables. Then when I query, I will get information related to only the 5 tables that I have access to, not all the 10 tables. And it is advisable, information schema can contain a lot of data. So it is advisable we put a where clause when we are querying the information schema. That is information schema. Now, if you go and see the information schema, randomly we'll do something. We have already done. This is related to the load history when we talked about the Snowflake. Let's talk about the storage metrics. What this thing will, it shows what is a table and what is a schema. In that, you can see when the table is created, when the schema is created, or if it is dropped, when it is dropped. It has time travel bytes. It has safe fail safe bytes, and it has active bytes. If you delete the table, then it falls under time travel bytes. After the time travel is done, it falls under the fail safe byte. So let's say something has come now is having a fail safe byte. Let us see what is this table. This is at the call center. If you go and see, do I have a table of call center? This is the table I created in Snowflake sample data. No. Snowflake sample data is what we got from by default. This is not present in my Snowflake database. But if you see, it is falling under failsafe. Look at me. Let us see what is the database for this. It's in the demo table. I would have dropped it. That is by dropped last week. That is by now it is saying that it is falling under the failsafe bytes. You can see something is falling under time travel bytes performance test. That is, we would have deleted this data today. Which one? The transaction large, sorry, transaction cluster content, and it is still falling in the time travel. Once the time travel is done, it falls under the failsafe. Any questions until now, team? So like this, you can either make use of this information schema views or the information schema table function. If you are in an account admin, you will see another database called a Snowflake. And Snowflake has another schemas called account usage, data sharing usage, organization usage, rate account usage. Here also it has an information schema that is a dummy. It doesn't have any significance. And there is another thing called an account usage in the Snowflake database. What is this account usage? Snowflake provides a data dictionary object, metadata, as well as historical usage data. And account usage is also a read-only. Is a Snowflake database is an example of Snowflake utilized shared data. This is shared by Snowflake team to us. We'll understand it more tomorrow when we talk about the share. And in Snowflake database, there is an information schema which is automatically created, and it doesn't serve any purpose in the Snowflake database. Now, what is the difference between information schema and account usage? Because if you go to the account usage, you will find a similar things. Load history. See, the similar kind of a table schema and all what we faced previously. Now, what is the difference between when to use information schema and when to use account usage? The account usage views and the corresponding views in the information schema use identical structures and naming conventions. But the difference is account usage has information related to the dropped objects. And for the data to reflect for you on information schema, it is immediately reflect. Whereas your account usage will take some time. And information schema can hold the data from 7 days, ideally to 14 days. And max 6 months based on the table or function we are defining. Whereas account usage, we can see last 1 year of data. Example. Let us take one thing, very simple demonstration we'll see. Here there is a columns in account usage. Let me see the information scheme. Here also we have databases. Let me drop one database here. Which database I'll drop? Before dropping any database, let me query both the information from information schema and account usage. Probably I will drop this party database. There is supply. If I go and check the information schema databases, party is a database. Okay, then this what I'll do is I will do it on columns. It has some 316 rows. If you see, this all information is from party. From which table? From party table. Same information we'll see whether it is present in the account usage. What I'm going to do, I'm going to go to Snowflake account usage and columns. Columns. This will have information related to whole of your account. So let me see what is the table where I'm filtering it. Sorry, where what I will do is where table name is supplier. Why is it I don't have SUP? Okay. It has some column name is supplier ID and supplier name. Let me see what is the information. Supplier ID and supplier name. Then why didn't I get many here? In this party, what are the tables I'm looking at? I'm looking at yeah. In public schema, I have supplier ID and supplier name. Now both these tables has information related to it. Is it nullable? Okay, or what is the data type like that? Even from here also we got the same information. Data type, what is it? We have a lot of information in the account usage, but a similar column level information is present. What is the character maximum length? What is the character octal length? What I'm going to do, let me drop this database itself part and see what is happening. It is successful. Let us see if it is there in the information scheme. It's not present. Let us see if it is present in the account usage. Still it is showing. So account usage, there is going to be a lag to reflect the information. And here it says is it deleted? Null. Right now it is null. But tomorrow or sometime you go and see the same query. Here deleted, yes. So it tracks the deleted objects and it updates this information, account history. But this particular information schema will not track the deleted objects. So this chart is important. What is the difference between account usage and information schema? So both has a similar kind of a data. Account usage includes the dropped objects. And latency is for information schema, it reflects immediately, whereas for account usage, it reflects some 45 to 3 hours. And historical account usage can retain 1 year of data and information schema from 7 to 6 months, maximum 14. It depends upon the information schema view or function you are querying. Any questions, team? Okay, let's take a 5 minutes break and be back. Right. Any questions, team? Just to recap what we have done today, we have seen more about caching, how this virtual warehouse cache will work. After that, we have seen how the clustering is going to work, and when we have to go with for a materialized view and when we have to go for a clustering. Then we have seen when we have to go for search optimization. Search optimization is like when you don't know on which column we are going to look at, and for a point lookup queries. That is when we go for a search optimization. So whenever the base data changes, your clustering will keep, or your background services will run in such a way that both your search optimization or clustering will keep happening. So if you want, you can turn them off at your will. Alter table, drop search optimization, or you can alter the table to turn off the clustering. Suspend, retest. By doing this, what will happen? Even when your base data is changing, Snowflake will not do the reclustering, or Snowflake will not do the search optimization, because it's not necessary. Whenever the data changes, you have to do this. Let's say there was a long gap and you did a recluster, or there is a huge amount of depth, clustering depth. Initially, your data was loaded like this, and you did a recluster. Now, after this, if you are going to linearly insert the data, June 9, June 10, June 11, there is nothing you can do for reclustering, because automatically you are going to, automatically Snowflake is reclustered, or automatically Snowflake is having the clustered data. Only initially there was data that was randomly inserted here and there, and data is distributed into micro partitions. And we saw that the performance is low, and the reason is this, because the data is not clustered, and you did the cluster one time, it's done. Then from now, whenever you are inserting the data, you are inserting linearly every day wise. There's no point of reclustering again and again. So you can turn off that cluster. And we have seen what is about information schema and account usage. Now we'll talk about shares. We'll talk about tomorrow. Let us talk about access management. When you logged into account, by default we have seen 6 rows. Marketing users is what I have taken. Let me delete the marketing users. By default, you have 6 rows: account admin, org admin, public, security admin, sysadmin, and user admin. Your topmost role is your account admin. Under account admin, we'll have security admin and sysadmin. Under account admin, we'll have security admin and sysadmin. Under security admin, we'll have user admin. Under sysadmin, we have public. These are the 5. 1, 2, 3, 4, 5. And the 6th one is org admin. And org admin is a separate system role that manage operations at an organization level. This role is not included in the hierarchy of system roles. Though we see six roles, org admin is a separate thing. When we log in as an org admin, and this is not, I will not be able to see org admin because this is not the main account for me. Let me log in. the main account. I'll show you. Here I'm logging as a tech trainer. Let me log into my main account. This is my main account. If you go, you can see organization. And we'll have an organization in your main account. All of you will have this organization. This is to maintain the different accounts within an organization. We have seen initially during our classes when I'm talking about the URLs, different kinds of URLs, and you can create a new account. And this is a separate role given to your parent account to maintain the accounts for that organization. So we have seen about the organization role, we'll leave it. Apart from that, we have 5 different roles: org admin, public, security admin, sysadmin, and user admin. And for that, this is the role hierarchy. When I say hierarchy, if you are giving some access to public, everyone would have an access. If you are giving some access to sysadmin, account admin will have access. If you are giving something to user admin, security admin and account admin will have access. If you are giving something to account admin, you need to explicitly give an access to other roles, else none of them will have access. Example. All our trainings we have done using an account admin. If you go to the worksheets, this is in an account admin. You can see this many databases. Let me create a new worksheet and let me log in as a sysadmin. See, I can see only customer analysis database. Let me log in as a public. I don't see that also. Let me go to the warehouses. Any warehouses are there? No. But as an account admin, I have 2 warehouses. Why? Go to your warehouses and see who has created. One is created by an account admin and one is created by a system admin. So whatever sysadmin has created, account admin can see. But whatever account admin has created, sysadmin cannot see unless you explicitly grant. Let us validate that also. So as an account admin role, I can see compute warehouse and first warehouse. Let me log in as a sysadmin. See, I can see only compute warehouse, not the first warehouse, because first warehouse is created by your account admin. So this role hierarchy is given by default. Public, user admin to sysadmin, then sysadmin and security admin rolling up to account admin. These are the system defined roles. Now, apart from the system defined roles, you can create other roles. You can create other roles. Those other roles, what are you create apart from this, are called the custom roles. Will be called the custom, like developer role, tester, marketing user, finance DBA, management. This can be couple of the system roles. Sorry, custom roles. Any roles you create outside these 6 roles that we have would be called as a custom role. Before going to the custom roles, let us understand what is the different significance of these different roles. Org admin, we have already seen. The org admin can create accounts in an organization. Can view all the accounts in an organization. And the maximum number of accounts in an organization cannot exceed 25. Right now, that is a hard limit. At max, most of the the clients use maximum 2 accounts. This for information purpose, it cannot exist 25 right now. You can view usage information across the organization. If your organization is having 10 accounts, you can see how much is your bill together for all the 10 accounts together. That is a use of an org admin. And you can see in a system, if you would have observed, when I went to Snowflake, if you go to the Snowflake database, there is a schema for organization usage. This is the place where we see the information, billing information at an organization level. Only for information, not needed for us. Then account admin. Account admin is a role that encapsulates system admin and security admin system defined roles. This is the top level role in system and should be granted only to limited number of users in your account. Only limited users should have an account. Security admin, it is the role that manages any objects and grants globally, as well as create, monitor, and manage users and roles. When I log in as a security admin, you can see the account information. You can see usage, billing, and all. Whereas you can see users, how many users are created, how many roles are there, policies and all. You can see the resource monitors and all. We have set it up. Go to the, I'm changing to security admin. See, as a security admin, I can see the resource monitors and all. I can see the sessions. I can see the policies. I can see the roles. I can see the users. But I cannot see the usage. I cannot see the billing. Security admin is used or is the role that manages any object grant globally. You want to grant accesses to any role, then security admin. And security admin inherits the privileges of user admin because user admin is rolled up to security admin. Then what the user admin will do? The role is dedicated to user and role management only. User admin can create users and can create roles. So indirectly, even system admin can, security admin can create roles and users because user admin is rolled up to security. Similarly, what system admin can do? System admin is the one who has a privilege to create warehouse. So I'm saying, oh, I logged in as security admin. Can I create a warehouse? Go try creating a warehouse. Test warehouse. Finish. It says insufficient privileges. But go and create as a sysadmin. Go and create the same thing as a sysadmin. Sysadmin can create 10 objects. Create a database for a sysadmin. You can create an object. Sysadmin can create an object. But your security admin will not be able to create an object. Try creating a database, tester DB1. Insufficient privileges. Because in the role hierarchy, when we talk about a role hierarchy, This role is to create an objects, databases, tables, schemas, warehouses. This role is to grant and accesses, create users and roles. Until now, what we have done, because account admin has both sysadmin and security admin access, we we did not face any issue, because as an account admin, you can create an objects and you can grant the privileges. Public role is the pseudo role that is automatically generated to every user and every role. And anything you grant accesses to public role, everyone would be able to see. Any role within the Snowflake environment would be able to see. Custom roles or any other roles other than the system defined roles, what we have seen, would be called as a custom role. Any questions on this role hierarchy? Go to and to understand better, let us do one exercise. Let us create a user. I will demonstrate. So what I'm going to do, let me create a user. Let me log in as a account admin, or let me log in as a security admin. There is no warehouse for security admin to access. Let me log in as a I cannot see a warehouse, but I can grant privileges on a warehouse. Go to the warehouses. As a security admin, I can see 3 warehouses. Why is it large? Let me change it to now. If I want to alter this warehouse, I will not be able to configure. Let me try changing it to X small. Let's see if it works. No. But let me log in. Who has created this? This is created by sysadmin. Either sysadmin can alter it or account admin can alter it, because account admin has the permissions. Now alter it as an account to access mode. Now I can grant a privileges. Let me log in as a again back to security. First I'll create a user or I'll create a role. I'm going create role. Instead of here, I can create here directly. Let me create using here. I'm creating a new role. Which role? I'm creating a developer. It has create role developer and grant role developer to role system. This by default will happen. Any custom role you create, it is advisable you roll up to sysadmin. Any custom role you do, you roll up to sysadmin, because sysadmin is the owner of the objects. That is why we are creating a role and we are granting the role developer to the role sysadmin by default. If you don't want, you can do very much. Let me query this. Now a role is created. Let me also roll up the developer to sysadmin. Now go to your roles. You can see a new role, developer created. Oh, security admin created. Now let me create a user. I'm creating a new user. I'll give the username as something like user1. Creating a username. User smaller, user one. And password I need to give. I'll just give user. User. Should we force change? Yes. See the query. Create a user, user one, password is this. Go to the next. What should be your login name? What should be your display name? First name, last name, email. It's optional. You can give. Preferences. What should be the default data warehouse or default name or a default? Default role will give it as a developer. Any default data warehouse, nothing. No, finish. What is the significance of this user? I'm going to log into the same account, but this time as a user. In your project, real-time project, every one of you is a user. Every one of you will be accessing the same URL. Everyone would have got one URL and everyone would be using the same URL. But your login names are different. First time when you log in, because I said enforce the password change, it will ask me for a new password. See, as a user, I logged into the same account. As a developer, I logged. What access I have? Only public role I have. Do I have access to any database? Nothing. No warehouse is available. No database is available. By default, any user by default will have public access. Now, if I wanted to get an access, who can give me an access? Either the owner of an object can give or sysadmin can grant. Let us see both. As a warehouse, as a security admin, let me grant one access. Whatever account admin has granted, let me grant. Grant privileges. Which privileges I am granting? Usage privilege. To whom I am granting? Let me say to developer. Grant. Now log into the user. Now check whether you have access to the warehouse. See, you got an access to only first warehouse. Because security admin has given access to the first warehouse to the developer. Oh, let me also grant an access to test warehouse. But test warehouse, I will grant it as a sysadmin because sysadmin is the owner. So sysadmin has an access right to grant an access. First, let me revoke this access. I'll show you again. If you go, now developer will not have access. So sysadmin is able to grant an accesses and revoke an accesses. Let me go to system admin. System admin doesn't have access to first warehouse at all. So he will not be able to give you access to first warehouse. But test warehouse is created by sysadmin. So even sysadmin can grant an access because he is the owner of it. So grant usage privilege. Now I am granting to a role public. I am not granting to developer. I am granting to a role public. Go to the worksheet as user one developer role. Check if any warehouse is available. It's available that I have granted to public. Why? Because anything you grant to public, everyone within the any role in the Snowflake would be able to have access to the objects. Now in your real-time project, every one of you are a user. And as a user, you have been granted accesses to certain warehouses. Now I don't have any database to work with. Then in your project related to your databases, you will be granted. You will ask your admin or someone to grant an access on certain databases. Go to security admin. Go to the databases. Say you wanted to have access to demo DB. Grant privileges. To whom or what privileges you want it to be. Usage. To which role? Let me grant it to public role. Grant. Now see, as a user, now when I refresh this, I should have access to this database. Demo DB. But do you have access to all other things? No. Then you need to give access to schema. Go to demo DB. Go to the schemas. Give access to public schema. What access? Just the usage access on the schema. To which role? To public. Because if you are granting something to public, even a developer would be able to see. Refresh it. Public schema. Does you have access to tables? No. Then grant an access to the tables. Which table you wanted to see? Let's say you wanted to have table demo. Grant privileges. Which privilege you want? Select privilege on a table. To which role? Let's say developer role. Correct. Now go and see, refresh it. You will see table demo. Will you be able to query? Very much. Because now you got select access. You were able to see that. Can you delete one? That's true. Well, you haven't created, given an access. I'll say not equal to 1. From this state. You have access. First thing. Insufficient privileges. Whom do you ask? You ask sysadmin in Snowflake. Sysadmin will go. Table demo. Grant privileges. What privileges you want to grant? Delete access. To which role? To your role, developer role. Grant. Now execute the same thing. 1 row. Number of rows deleted is 1. Why? Delete from table. Where? Oh, I deleted all the 4. All the 4 are deleted. Go and see now. There will not be any data. So this is how your role hierarchy works in Snowflake. You have seen, I created a user, I created a role, and how I'm able to give the accesses. Any questions here? For sure, you should have a question. In your current project, whom are you requesting accesses for? You should be dropping a mail or someone should be giving you an access, right? Think.
Normally, we used to ask access to either the DBA team or DevOps team.
Yeah. This is how they grant you the accesses. So first your users are created. First your user is created, username and password. That's why sometimes if they give you should change password, then it will prompt you to change password and you continue to use it. Then you are given access to the warehouses and databases or table level. And this, whatever is the screen I showed you, it's very important. Your roll up to how your accounts are rolled up. All this information, because you can all have access to this documentation. This is very important. Your account admin, this role hierarchy. This is the only thing that would be needed for your Snowflake course certification. You can have number of questions on this particular topic. Let us have a quiz and conclude today's session. Give me a minute. I'm sharing my screen. What is the most powerful role in Snowflake?
Account admin.
Account admin.
Account admins.
Yes. Which role is granted by default to every new user in Snowflake?
Public.
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 It's public, correct. The security admin and system privileges are automatically contained in account admin.
Yes.
Yes.
If a user doesn't have any role assigned, their default role will automatically be
Public.
any other option? Why is it not none?
Because public role is assigned by default. So
When I
is
when I create for others, when I created a user, if you observe, this is as a security admin. Let me go to the account. Now, when I created a user, I created user one and I set him the default role as developer. What will happen if I create a user two? New password I'm giving. I'm not enabling this force change password. Next. If I don't give a default role, what will happen? The question is, if I don't give a default, before I have given a default role of developer. Now, if I don't give a default role, their default role will be none, no role will be available, or will they be given a public role? Is the question. Any? So, few of you have said public. Any other option? I have created a user. Okay. Now there is no default role. Previously, I have defaulted the role to developer. Now let me log into the new user. User 2. It will not ask for a password because I did not enable that option to change the password. See, by default, if I don't assign anything, it's by public. Go and see this. Refresh my this account. If you see my user 2, yes, that I'm not able. Though there is no now I'm not able to see somehow. Even if you don't assign any default role, it is going to be public. That is the reason in our chart, in our role hierarchy, all your custom roles are placed above public. Any user you create, by default, they are going to have public. Anyone has any questions here? It is not possible to change your session's role once you establish a connection to Snowflake. True or false?
False.
False.
Where you can change the session role?
One
How
the
you-
role.
Mhm. Or if you're logging in with SnowSQL, then
Use role.
Here only we can change.
correct. So if you're logging in through the UI or Snow CLI, now you are in a developer role. Use role, because if you see, observe, I have given access to database, schema, and table. Table demo I have given only to developer. Let me go to public. I can change using use role. Public. Refresh it. I did not give access to the table, though I have given access to database and schema to public, where you can go and check. As a security admin, if you go and see the databases, go to the demo DB, you can see what accesses you have granted. Go to the demo DB. If you go to the schemas, for public schema, I have granted access to public. Go to the table. Table demo, I granted access to developer. One thing, if you observe, I am granting an accesses to the roles. Nowhere I am granting accesses to the users. Here I am granting accesses to the roles. I'm creating a users and I'm assigning the users to the roles. Now all your role mechanism is happening via roles, your privileges and all. That is why this is called role-based access control, RBAC. Because for sure there should be a role and users can be assigned only to the roles. And you can grant privileges to the roles. You cannot grant privileges to the users. If you're not assigning any role, by default they're in public role. But if you want to grant privileges, you need to, that public role should have got the privileges. Any questions? Is it clear, everyone? whatever we talked about is because you are granting privileges to the roles, it is role based access control.